In this video, we're going to talk about arguments and validity, and we also going to see a lot of examples. We're going to see if the arguments is valid or not. So I hope you guys can enjoy the video. So let's start. But before I start, I just want to say that there's also another method to do this one, and that is by using a table. So, because there's some situation that you cannot use principles and some methods. So for that reason, uh, actually, I got a video on that. I want you guys to check that out. I made a video on how to know if the values, if the argument is valid or not by using a table. So I want you guys to check that out. But in this video, we're gonna see those principles. So let's start. Well, the basic thing is as you guys know, I believe that you guys know this. So if it is valid, it means that it is true, and if it is invalid, it means that it is false. So this is like the basic things. So let's just see it in examples, and you're gonna see the concepts, and you can understand them. Okay, so when we see it in examples, we got example over here. It says that p and p plus q, and they want us to find this value or the q value. So what I want to do is just the first thing I want you guys to do all the time when you are dealing with these arguments and validities is see if there is anything that is not connected or that is not connected to other letters. So this is alone, this is not connected to other letters. So if there's anything that is not connected, it means that I can't use my principles. But if this one was connected to another letter, it means that I cannot use these principles. I gotta use the table. So this is how it works. So since I got this one over here, I'm gonna use my principles. So I'm gonna say that P is equal to true. So, and then after that, we just can also, this is actually my principle. P is equal to true is my principle. And also P implies Q equal to true is also my principle. So these two are my principles. So since I got this P equals to true, I can substitute this. So when I substitute, I'm gonna get P implies Q will equal to true. So as you guys know in implications, uh, this statement can only be true if Q is true, unless it cannot be true. So for that reason, this means that Q is true, because true implication false is always false. So for that reason, I don't want my statement to be false. So for that reason, Q is always true. So it means that I get the answer. They want us to find this value Q. So I just get the answer. It is true. So since it is true, it means that it is what? It is valid. So this is the quick way to find or to know if the argument is valid or not. So this is all you have to do is just the first thing that you have to do is just see if you can use the principle or not. So and then after that is just put this principle p equals set p equals true, and then after that just use this implication or the second principle, and then by this implication rule Q cannot be false because if I make Q false, my whole statement will be invalid. So for that reason, it must be true. So I get the answer that is valid. So this is it, and this is what you gotta do. Now let's do the second example, and it will be more verified for you guys. So let's do it. Okay, now this one looks a little bit different though, because we've got a lot of letters over here. In this example, but I want you guys to stop the video and try by yourself and see if you get the answer. Well, okay, so over here, let's see. We still got one letter that's not connected, and that is, as you guys can see, this is R. So I'm gonna take R as my principal. So I'm gonna say that R equals to true. And actually, they want us to find this value, and that is Q. So my principal R is equal to true. Okay, so and then the second step that I want to do is just R implies P will also become true because this is also my principal. Okay, so and then so let me just substitute. So when I substitute, I'm gonna get true and P will equal to true. So this is the same as the previous one. So P must be what? P must be true because true implies or true implication false cannot be true. It would be false. So for that reason, I'm gonna say P equals to true. Now, this is not the thing that they wanted us to find because they say that we gotta find this Q value. So for that reason, we also got another statement over here. So let me write this statement. So it says that P implies Q. So P implies Q. So P implies Q is also true because this is also my principle. So when I substitute this, I'm gonna get true implies Q will equal to true. This is also the same as the previous one. So Q must be what? Q must be true. Unless my statement will be valid. So Q must be true. So for that reason, my statement also be so the whole statement will be what? It will be valid. The whole statement will be valid. So I'm just gonna interpret what I've been doing. So the first thing that I did is just I found out if there is anything that is not connected, and I find this one. So this is ours. So I say this equal to true because this is my principle. And then the second thing that I did is just I've got another statement over here or another function over here. So I also set this one to true because this is also another principle. And then since I got R that is equal to true, I substitute this over here on the R section. And then after that, true implication or true implies P become true if P is true, unless it will be false. So for that reason, all the time, my principle must be true. My principle must be valid. So for that reason, I set this P true. It must be true. So when I set this P to true, it became P became true. But that's not the thing that they want us to find. So for that reason, I got another statement for over here because since I'm finding the value of Q, so I also set this statement to true because this is also another principle. And then after that, I'll substitute this P over here, and then true implies Q become true. That's my premises. So my premises must be valid all the time. So for that reason, uh, Q will be true unless my statement would be invalid, and I don't want that. So for that reason, Q become true. So and we get it. So we get the answer, and that is valid. So this is it, and this is how you deal with the type of questions that you can use principal methods. So I hope you guys enjoyed the video. So now you just gotta watch the video that you can use a table, because as I told you guys, there's some situation that you cannot use these principles. So you gotta watch the table method because that's gonna help you a lot with the type of question that you cannot use these principles. So, but this is it for this video, guys, and thanks for watching, and have a nice time.